Hello and welcome. We present a new video, which gives you some details about our DMS demo project. DMS is an abbreviation and stands for Distribution Management System. The video will cover the following topics. An overview of our grid, which is displayed in the World View screen. Example how to operate a substation. Representation of the grid in a GIS screen. Event list, alarm list and reports. Use case of situational awareness by simulation of a short fault. Calculation of the fault locations and visualize it with a marker done by Zenon. Show the fault location in the GIS screen. Okay, now let's start the presentation. The demo project is delivered as a Zenon project backup. When you open this backup in the Zenon editor and start the runtime, you will see this screen. The screen layout is divided into three areas. On top we have the menu bar. Then we have the main screen. And, at the bottom, we have the information bar. The first action is a user login. You can use username and password as defined in the editor or log in directly as an operator or supervisor. The next step is getting an overview of our grid. We can open the single line diagram via electricity and 30 kV grid. Our grid consists of 3 main substations, which are the gray areas here, and 75 secondary substations. The secondary substations are represented with the name and a symbol. The Overview button opens the World View control, which again gives us the overview and a station list. When we zoom in, we get a more detailed view of every single secondary substation with the possibility of operation. For example, we can operate this substation and retake the supply from the substation. Some interlockings come up which we can overrule, and now the secondary substation is unsupplied. This information is also shown in the menu bar. Here we have one station with 655 customers, which is unsupplied. We will now supply it again. With the menu we can open detail screens for every main substation. Here we have the single line diagram of one of the substations. The feeders are fully operable. In addition, we have some detailed information about our transformers. The transformers are equipped with a tap changer and some alarm annunciators. We can open the GIS screen via the menu. As the single line diagram gives us a topological overview of our grid, the GIS will represent the grid in a geographically correct view. Here the empty map provider is selected, so we see an empty background. This view shows all the lines and the secondary substations. The colorization of the elements is done by the automatic line coloring. We can select another map provider in order to also see a different map. So you have the possibility to display the grid on various maps with different topologies, according to your individual needs. The demo project of course contains a sequence of event list as well as an alarm list, some trends and some reports. In the next step I would like to demonstrate a use case for situational awareness. Therefore, I will trigger a simulated short fault. In this dialog, we can define the position where the short fault should occur. Now the short fault is triggered. The operator gets an alarm annunciator in the menu bar, as well as an alarm in the alarm list. When we open the menu, we see that the alarm was triggered in one of the substations, This is also displayed on the grid. As it is a little bit tricky to find the alarm area, it is possible to change the color mode into alarm mode. In this color mode, the single line diagram is grayed out except for the faulty area. We change back to the normal color mode. We see that the circuit breaker has tripped and Zenon already has colorized the faulty area. Based on the impedance value of the protection device, Zenon is able to calculate the fault location and visualize it with a defined marker. This information is also available on the GIS view. With the empty map, we can clearly see the faulty area and the faulty lines plus the fault location. With this information, we can guide our maintenance crew to the exact position of the fault. Back to the single line diagram. We can acknowledge the alarm and isolate the fault. Therefore, we will open the devices next to the fault. We do this by manual correction. This operation caused the protection device to clear the given state. Because we opened this device shown here. Now we can close the circuit breaker again. So we close the ring from the parallel side in order to supply our secondary substations. Now the fault location is isolated and the maintenance crew can do his work and repair the short fault. Thanks for your attention. We hope you enjoyed the video.